In the last class, we have seen the experiment liquid limit of soil by classical random method. And so now we will see plastic limit of soil. So I'm sharing the screen. I hope it is visible to you. Uh, I'm sharing the screen. Uh, I hope it is visible to you. If not, you just drop a message in the comment box. So determination of liquid limit we have seen the last class. So today we will see one more experiment with respect to consistency limit, that is determination of plastic limit of the soil. So how do we determine the plastic limit of the soil? So the plastic limit of fine grained soil is the water content of the soil below which it ceases to be plastic. It begins to crumble when rolled into threads of 3 mm dia. So how you are defining what your plastic limit? Minimum water content or the water content of the soil below which it ceases to be plastic state. So plastic and elastic state, if a material regain its original state on the removal of forces, then it is called as elastic state. If it does not regain its original state, then it is known as elastic state. So the plastic limit of the fine grained soil is the water content of the soil below which it ceases to be plastic. It begins to crumble when rolled into threads of 3 mm depth. So what is the specification? This test is done to determine the plastic limit of the soil as per IS 2720 part 4 1985. So take out 30 gram of, so what is the specification used? So this test is done to determine the plastic limit of soil as per IS 2720 part 5 1985. Take out 30 gram of air-dried soil from a thoroughly mixed sample of the soil passing through 425 micron meter ISA. Mix the soil with distilled water in an evaporating dish and leave the soil mass for 24 hours. So what are the equipments required? Porcelain evaporating dish, flat glass plate, a balance accurate to 0.01 gram, drying oven maintained at 110 degrees Celsius, weighing dishes, non-absorbent plates, flexible spatula blade approximately 102 mm. So what is the theory? The plastic limit is the moisture content that defines where the soil changes from semi-solid to plastic state. So what is plastic limit? Plastic limit is the moisture content that define where the soil changes from a semi-solid to plastic state. It may also be defined as the water content at which the soil starts crumbling when rolled into threads of 3 mm dia. Use the paste from liquid limit test and begin drying. May add dry soil or spread on plate and air dry. So what are the precautions you need to take while performing this test? Soil used for plastic limit determination should not be oven dried prior to testing. So the soils which are used for plastic limit determination should not be oven dried prior to testing. After mixing the water to the soil sample, sufficient time should be given to permeate the water throughout the soil mass. Wet soil taken in the container for moisture content shall not be left open. The container with soil sample should either be placed in desiccators or immediately be weighed. So what is the procedure? Select a representative sample of fine grained soil of about 20 gram or more passing through 420 micron ISC. Mix it with distilled water throughout on a glass plate such that the palm of the soil can be rolled into a thread of 3 mm dia. Allow some time for the proper distribution mixed with water. So what you have to do, you have to select a representative sample of fine grained soil of about 20 gram or more passing through 420 micron ISC. After that, what you have to do, mix it with distilled water thoroughly on a glass plate such that the palm of the soil can be rolled into a thread of 3 mm diameter. Allow some time for the proper distribution with water. Take about 10 gram of this wet soil and roll it into a thread on a glass plate with the palm of the hand. The rolling must be such that it forms a thread of 3 mm diameter. If the thread cracks before attaining 3 mm diameter and add little more water, knead it and roll it again. The rolling can be done to the meter less than 3 mm. Mix some dry soil. Knead it to remove some extra moisture. This process has to be continued till the sample crumbles just at about 3 mm depth. Collect the crumbled soil at least 6 gram and measure its water content. Repeat the process to get at least 3 water content determination after they have been in the over at least 16 hours. The average of water content so form is the plastic limit of the soil. So how we are determining the plastic limit of soil? In the first step, what we are doing, we are taking the soil sample of about 20 gram, adding some amount of water to it. The soil should be passing through 424 micro ISC. After that, we are making thread of this soil such that of 3 mm diameter. If it is less, then add some water. It should not crumble. If it crumbles, then it means that liquid plastic limit is not okay. So repeat the process to get at least 3 water content determination after they have been in the oven at least 16 hours. The average of water content so obtained is the plastic limit of the soil. So tabular column, if you see the water content of 3 mm soil, W1, W2, W3, W4. W1 is weight of container W1 gram, weight of container plus wet soil W2, weight of container plus soil W3. Water content W is equal to W2 minus W3 divided by W3 minus W. The average water content W will be equal to how much? W1 plus W2 plus W3 plus W4 by 4. So what are the pre-bio questions? Define plastic limit of soil. So how you will define plastic limit of soil? Plastic limit of the soil is nothing but minimum water required to make a paste of soil so that it does not crumble. That is known as your plastic limit soil. How is plastic limit computed in the laboratory? So in the experiment just now we have seen what is the practical significance of determining plastic limit of soil. Plastic limit of soil helps us to identify how much amount of water is required to change the state of soil from solid to liquid, liquid to plastic. Now, what is plasticity index? Plasticity index IP is nothing but difference between liquid and what is toughness index? Toughness index is nothing but IL by IP divided by LT. So the plastic limit of soil average water content is this much. Plasticity index is equal to WP minus WI. So what is the verification of validation? Determine the plasticity index IP, which is the difference between liquid limit and plastic limit. Following table is the standard values. Soil type sand, W1 WP IP, silt 30 to 40, whereas it is for silt WP is 20 to 25 and IP is 10 to 15. For clay it is 40 to 150, for W 25 50, and IP is 15 to 100. So the plastic limit of the soil is this much and plasticity index is this much. And the type of soil is this much. The post-bio question, what is meant by unified soil classification? Unified soil classification, you need to understand in detail in the theory part, what is A line and U line. So yes, this also you need to, what you can see, find out what is liquidity index and consistency index that we have found out just. So one more experiment we will show today. It is determination of shrinkage limit. So it is somewhat what you can say lengthy experiment. To determine the shrinkage limit of soil. The value of shrinkage limit is used for understanding the swelling and shrinkage properties of previous soil. It is used for calculating the shrinkage factor, which helps in the design problem of the structure, weight of the soils, listing of the soil. It gives an idea about the suitability of the soil as a construction material in foundation, roads, embankment, and dam. Specification. The test is specified in IS 2720 Part 6 1970 to this 30 gram soil passing 425 micron C is used for the test. So which type of ISC is used? IS 2720 Part 6 1970. 30 gram soil passing through 425 micron C is used for the test. Equipment required two number of porcelain evaporating dish about 12 centimeter within a flat bottom. Three number of shrinkage dish made of non-corroding material having a flat bottom 45 mm diameter and 15 mm high. A glass cup of about 50 mm diameter and 25 mm height. Two numbers glass plates of size 75 cm, one plate of plain glass and the other with three metal prongs. Spatula bands accurate to 0.01 gram oven etc. Mercury, desiccated and other accessories. Theory. As the soil loses moisture, either in its natural environment or it's by artificial means laboratory, it changes state to plastic state to semi-structure and then to a solid state. The volume is also reduced by the decrease in water content, but at a particular limit, the moisture content causes no further volume change. A shrinkage limit gives a quantitative indication on how much moisture can change before any significant volume change and also indicate or change in volume. The shrinkage limit is used in areas where soil undergo large volume changes when going through wet and dry cycles. Shrinkage limits are required to be determined on two types of soil. They are remolded soil and distant soil. Other shrinkage factor, that is shrinkage ratio. Volumetric shrinkage may also be calculated from the test data of shrinkage limit. Shrinkage ratio is the ratio of given volume change expressed as a percentage of dry volume to the corresponding change in water content above the shrinkage limit. And the volumetric strain is the decrease in volume of soil mass when the water content is reduced from given percentage of the shrinkage and which is expressed as a percentage of dry volume of the soil mass. So what are the precautions you need today? Do not touch the mercury with gold rings. The water content of the soil taken in shrinkage dish should be above liquid limit but within 10% from liquid limit. To prevent the cake from adhering to the shrinkage dish and consequent cracking of the dry soil paste inside the shrinkage dish should be greased with Vaseline. During filling the shrinkage dish with soil paste, sufficient tapping should be done to remove entrapped tails. The dry soil The dry soil paste should be wet soon after it has been removed from a desiccators, otherwise it picks up the moisture from the air. Test should be repeated at least 3 times for each sample, and the average of the result should be obtained. No air should be entered under the soil mass when pressing up the glass with prongs is being carried out. Procedure. So what is the procedure? Select a representative sample of soil for about 100 grams, passing through 425 micron sieve. So what you have to do in the first step, select a representative sample of soil of about 100 grams, passing through 425 micron sieve. After that, take 30 grams out of it and place the same in an evaporating dish. Mix it thoroughly with distilled water and make it into a thin paste for readily filling into a dish free from air bubbles. So determination of mass and volume of shrinkage dish. How you determine the mass and volume of shrinkage dish? Take a shrinkage dish, clean it and find its volume. Mass, find its mass, correct 2.1 gram. M3 gram. To determine its volume, place it in an evaporated dish. Fill the shrinkage dish with mercury till the excess overflows evaporation. Coat the inside of the shrinkage with a thin layer of silicone grease or Vaseline. Place a part of the soil paste prepared earlier at the center of the dish so that it may occupy one third of its volume. Next, find the mass of the wet soil with the dish immediately after filling M1 gram. Keep the dish with soil exposed to air until the color of the pad turns from black to light. Select a glass cup with a flat bottom and keep an evaporating dish. Fill the cup with mercury and remove the excess mercury by pressing the glass plate with three prongs firmly over the top of the cup. Remove the split over the mercury. Take out the glass plate with the prongs. Place the dry soil of the surface of the mercury. Force the soil pat into the mercury by pressing with the same glass plate with the prong. Collect carefully the split over mercury and find its mass mm. The volume of the dry soil pat VD is equal to mm divided by 13.6, where 13.6 the density of mercury in gram per centimeter. Calculation of shrinkage limit WS. Mass of wet soil M not equal to M minus M3. Mass of dry soil M is equal to M2 minus M3. Volume of shrinkage dish. Volume of wet soil. Volume of dry soil. Shrinkage limit is given by WS equal to MS minus this map. Shrinkage limit of undisturbed cell. In this case, G is also known as one. The equation can be used for determining WS equal to. For the undisturbed soil, we need to know the value of an undisturbed dry port soil ball of 45 and thickness 15 mm. Now we prepare the dry portion and then dry over the same, find its mass and put desiccated and then its volume VD by mercury displacement method. WS may now be found out by using the equation W is equal to VD by MS minus 1 divided by into 100. So what are the pre-bio question? How to measure shrinkage limit of soil? Just now we have seen why is mercury used in international nuclear of soil? What is the density of mercury? 13.6. 13.6 is specific gravity. If you multiply this with 1000, you will get the density. It comes out to be 1360 kg per meter. What is the difference between undisturbed and remolded sample? Undisturbed sample means it is not uniform, whereas remolded soil is nothing but a soil which is disturbed and it is again remolded. Is the dry unit in the same? No. What is meant by thingotropy? Thingotropy result. So shrinkage limit W is equal to this much. Value of shrinkage limit varies from 13 to 626. The shrinkage limit of the soil is this much. Post bio question. What is shrinkage limit of soil? Just now we have calculated. If the water contains microorganisms, the water is prepared. The shrinkage will also increase. Instead of morgue, can we substitute? No. So the next experiment is very interesting. That is determination of maximum determination of maximum dry density and optimum moisture content by standard Proctor compaction method. So, what is the experiment? Determination of maximum dry density and optimum moisture content by standard Proctor compaction test. So, aim of this experiment is to determine moisture content by dry density ratio by standard Proctor test. Compaction is the application of mechanical energy to a soil so as to rearrange its particles and reduce the voids ratio. It is applied to improve the properties of an existing soil or in the process of placing fields such as in the construction of embankments, road buses, runways, earth dams, and reinforced earthwork. Compaction is also used to prepare a level surface during construction of building. So what is compaction? Compaction is nothing but application of mechanical energy to a soil so as to rearrange its particles and reduce the voids ratio. तो व्हाट इज कॉम्पैक्शन एक ऐसा प्रोसेस है जिसकी मदद से हम क्या कर रहे हैं आपकी जो सॉइल है उसको कॉम्पैक्ट कर रहे हैं यूनिफॉर्म कर रहे हैं और उसके अंदर जो ग्रेन्स हैं उसको इस काबिल बना रहे हैं कि वर्ड्स रेशो नहीं रहे इसमें it is applied to improve the properties of an existing soil or in the process of placing fields such in the construction of embankments, road buses, runways, earth dams, and reinforced earthwork. Compaction is also used to prepare a level surface during construction of building. This is usually there is usually no change in the water content and in the size of individual soil particles. Specification. The experiment is conducted as per IS 2720-7 1980. Experiment equipment required. Typical equipment for proctor test is given as follows. Other accessories are balance over straight edge, use metal hammers, etc. Theory. The objectives of compaction are to increase soil shear strength and therefore its bearing capacity, to reduce subsequent settlement under working loads, to reduce soil permeability, making it more difficult for water to flow through. To assess the degree of compaction, it is necessary to use the dry unit weight, which is an indicator of compactness of solid soil particles in a given volume. The laboratory test is meant to establish the maximum dry density that can be attained for a given soil with the standard amount of compactive effect. Bulk density root equal to M2 minus M1 by V. Dry density root equal to root divided by 1 plus W. So the dry density rho d for 0, its one line is rho d equal to GPW divided by 1 plus WG by S, where M1 is the mass of mole used for compressed test, M2 is the mass of mole plus compacted soil, M is mass of wet soil, V is volume of mole, rho W is density of water, G is specific gravity of soil, W is water content, and S is degree of saturation. So what are the precautions we need to take while carrying out this experiment? Thoroughly break up the sample by running it through the screen before compacting in the mold, found with a moisture range from optimum to 4% below optimum. The closer to optimum the moisture content is, the more accurate the test will be. Make sure the clamp on each mold section is tight. Make sure the wing nuts on the base plate are secured with equal tension. Place the mold on a solid block that is supported on a film or pavement. Hold the rammer vertically so that it will fall freely. Drop the 25 kg rammer weight freely. Use exactly 25 blows on each layer. May place 3 equal layers in the mold. So what is the procedure? Select a representative sample, soil sample of about 25 kg. The materials used for the test must be finer than 20 mm air dry sample. Add sufficient water to the sample, about 70% for sandy soil and 10% for clay soil, which will be less than the estimated optimum content. Mix the soil thoroughly and keep it in an airtight container for a period of 20 hours. Fix the mold to the base plate after cleaning its inside surface. Find the mass of the mold with base plate M1. Attach the extension collar into the mold. Take about 2.5 kg of soil in an airtight container and compact it in the mold with the equals layer. Compacted by giving 25 blows by the hammer, weighing 2.6 kg and dropping from a height of 310 mm. The compaction must be uniform over the whole area, and a spatula scratches each layer before adding another layer. The filling must be such that the layers projects into the collar by about 5 mm. After the completion of collar compaction, remove the collar and remove the base plate and the soil M2. Remove the soil from the mold by making use of an ejector and take a representative sample for water content determination. Carry out the test 3 to 4 times by repeating the steps from E onwards. Each time use a fresh soil sample. Observation and tabulation. The following observations were made on the compaction of soil by standard Proctor test. 6 tests were carried on selected sample by varying the water content. Water content of samples of each test were found out by the procedure explained earlier. The test results are tabulated in this way. Weight of soil for varying water content is mass of empty mold m gram, volume of mold centimeter cube, mass of mold plus sample m2 gram, mass of wet soil m gram, weight density roti grams per centimeter cube, water content percentage, dry density roti gram per centimeter cube, W1 for calculation of saturation line, rho d is gram per centimeter for S equal to 100%, rho d to gram per centimeter for 80%. Plot dry density versus moisture content and find out the maximum dry density and optimum moisture content for this. Also mark 100%, 80% saturation line. Pre-viva questions. What are the pre-viva questions? What is the difference between standard Proctor test and modified test? What is the relative density of soil? What is void ratio? What is zero its one? What is the practical application conducting statistical test? How do you determine OMC of soil? So the result is maximum trace density ρ is equal to gram per centimeter cube. Optimum moisture content W is equal to percentage. Verification and validation. The peak point of the compaction curve. The peak point of the compaction curve is the point with maximum dry density. So how you will define peak point of compaction curve? The peak point of the compaction curve is the point with maximum dry density corresponding to the maximum dry density. ρD max is a water content known as the optimum water content. The optimum water content is the water content that results in the greatest density for a specified compactive effect. Compacting at water content higher than the optimum water content results in a relatively dispersed soil structure. Parallel particles orientation that is weaker, more ductile, less pervious, softer, more susceptible to shrinking and less susceptible to swelling than soil compacted dry of optimum to same density. Zero air voids line. The curve represents the fully saturated condition as equal to 100%. It cannot be reached by compression. So what is the conclusion? The maximum density of the soil is dashed with an OMCF dash. This indicate after W percentage any additional water addition, there is no gain in strength of soil. So what is happening is, if suppose the maximum density of the soil is known to you with an optimum moisture content of this one, this indicate that W percentage any additional water, if there is no gain in strength of so optimum moisture content value it has already achieved. So what are the post-viva questions? How is compaction different from consolidation? So this already I've studied if you are explore what you can say in today's level also. Compaction and consolidations are different. They are not interconnected to each other. Or did you watch any civil engineering construction compaction schedule explain? Videos I have watched for compaction. Is there any other method other than standard method to determine maximum density? That needs to be find out. So the next experiment is determination of permeability of soil sample by constant head method that we will see in the next class. If you have any doubts, you can just drop a comment. Just drop a message in the comment box. And if you have any queries, you can email me at nadimedical@university. Also, you can make me call in the evening hours at 8553 171859. Thank you. Have a nice day. Just the dry density rho d for 0 its one formula you remember. Rho d equal to G capital G, it is specific of solids. Rho W divided by 1 plus WG divided by S. And IS code, which IS code is used for determining the optimum moisture content and maximum dry density. IS 2720 7 1980. This code is used. And what are the equipment required? Typical equipment for profit test is other accessory balance over straight X use metal hammer. So these are the instruments used. So what do you mean by exactly optimum moisture content or dry density? So before understanding this, you need to understand what is compaction. Compaction is the application of mechanical energy to a soil so as to rearrange its particles. I hope you have understood it. So what do you mean by peak point of compaction curve? The peak point of the compaction curve is the point with the maximum dry density corresponding to the maximum dry density rodents. So 0.8 volts curve is also there. The curve represents the fully saturated condition is equal to 100%. It cannot be reached by compaction. So we are left with only two, three experiment, that is permeability of soil. Next is falling at permeability test. So two test on permeability. Next, liquid limit by static point penetration. Determination of shear parameter by that test also is there. Shear test. Unconfined compression test. After that, we will have demonstration. I hope you have enjoyed it. We will close the meeting. If you have any doubts or queries, you just drop a message in the comment box, or you can mail me at navimerdinpayment.university. You can also call me at 8553 17159. So I'm ending the class now. Have a nice day.